So Michael is a mobile developer at Touchlab. He has 4 years of experience developing Android apps and 1.5 years of experience working with Kotlin Multiplatform and production apps. When Michael isn't behind a keyboard, he is behind a wheel at a racetrack doing 14 plus hour endurance races with his team. Michael, the stage is all yours. Me and the trainer are going to leave now.
All right. Thank you, Cassandra. Hi. So, as you said, I'm Michael. I work for a company called Touchlab. We do mobile and Kotlin multi-platform contracting consulting. We've recently been hyper focused on becoming a big name in the space of Kotlin multi-platform, and we've been helping multiple clients get up to speed with using KMP in production. So to start off, what is Kotlin multi-platform? So if you're doing mobile dev at all, you're probably familiar with Kotlin as the Android language, but it's actually a lot more than that. So Kotlin can actually compile into multiple different targets. JVM is obviously the one that is used on Android and used the most, but you can also compile Kotlin for iOS, JavaScript, desktop, and even WebAssembly. And using this, you can share code to be able to reduce redundancy across all your apps. So you only have to write some of your business logic and other things one time in Kotlin and share it across many different targets and different projects. And when you're using Kotlin multi-platform, you can have platform-specific code that is able to interact with the actual platform APIs. So you're probably thinking of one of the many cross-platform frameworks that have come and gone over the years, and wondering how Kotlin multi-platform is different and why you should choose it over those frameworks, or in general, if you've looked at those frameworks and decided it's not for your organization, why you should consider Kotlin multi-platform instead of just sticking with native development. So with most cross-platform frameworks, all the code is shared. So it's really useful for getting an app together really quickly. So you get a lot of speed, but you lose a lot of flexibility. And there's a really high initial investment for switching to a platform like Flutter or Xamarin. And there's also high long-term commitment. So if you want to try out Flutter, if you already have an app, you have to basically usually rewrite your entire app. And once you do, you can't really go back to doing native development unless you want to do another rewrite of your full app. And you're also really dependent on the framework itself. If there's any new functionality that comes up on the platform, then you typically need to wait for that framework to actually support it. And in the unfortunate scenario that the maintainers stop maintaining that framework, you're basically just stuck at whatever they supported when it was sunsetted. Kotlin multi-platform, on the other hand, lets you share only what you want. So it's super flexible in what you want to share between your platforms, and you can share as much as you want or as little as you want. So that can go from uh, one line of code that is a crucial piece of business logic, all the way up to even UI with Jetpack Compose multi-platform. It can also be adopted into existing apps, so you don't need to rewrite your app or really change any of your existing code to be able to use Kotlin multi-platform. You can write one small thing in shared code today and be able to use it from both iOS and Android apps that you already have that have been worked on for years. And you can also use all of the newest Android and iOS technologies and best practices and things like that, since you still have a native iOS and Android app. So you're free to adopt anything new as it comes along, like Compose and Swift UI. And this also applies to platform specific libraries that you already like. So if you have something that's doing something and working really well for you on a single platform, using Kotlin multi-platform isn't going to limit you from continuing to use that library that you've gotten used to. So how does it work? Basically, you have a common Kotlin module that at compile time will generate an Android AAR, which is basically Android's binary library format. Think of it as just a jar for Android. And also an iOS framework. And then your iOS and Android app will consume these two things. Your Android app will consume the AAR via Gradle, um, basically as you would consume any other Android library or Kotlin module inside your project. And the iOS will get your framework through either CocoaPods or Swift Packet Manager, or you can set it up to just pull it in manually. And at this point, your shared code is really no different than any other library that your app would use. So to your native apps, all it sees is it has this library with functions in it and things in it that it can use. And it doesn't really know that this library came from Kotlin code. And since you have these two native apps, you can pull in other libraries that are specific to the platform alongside your KMP libraries. Like I said, if you have libraries that you really like or new things that you want to try, Kotlin Multiplatform isn't going to limit you from pulling those in. And one thing that's really useful is you can also bring in libraries that are made for Kotlin Multiplatform, and those will also be included in your shared code. And this makes working with multiple platforms really easy because a lot of the stuff that cares about the platform it's running on, you can just defer to a library and let it handle it and only write shared code. If you've looked at all into KMP, you might have seen these two acronyms and be a little confused on what the difference is. So KMP is Kotlin Multi-Platform Projects, or the shorter form that I like to remember it as is just Kotlin Multi-Platform. And that's just referring to all the targets that KMP supports. So that's JVM, iOS, native desktop, JS, WebAssembly, and any other platforms that they might add in the future. KMM, which is Kotlin Multi-Platform Mobile, is just a subset of KMP that only includes Android and iOS targets. And you may have heard of a beta that's coming up in this fall that's specifically referring to KMM, not KMP. So JetBrains has chosen to focus on getting Kotlin Multi-Platform Mobile stable and into a beta release so that they can productize it first while still working on the more experimental parts of KMP alongside it. Today, we'll mostly focus on KMM since this is a mobile summit, so it's the most relevant. So, what does your shared code look like? In your project, you're going to have a shared Gradle module of Kotlin code, and it's going to be split between common code directories and platform specific code directories. So in your common code directory, you can put anything that's platform agnostic. So if it doesn't interact with a platform at all, you can pull it and put it directly into your common directory and basically get multi-platform code for free. And then in your platform specific directories, you'll have an Android directory where you can access everything from the Android platform, like Bluetooth or Android XP models or activities or whatever you want to be able to interact with on Android. And then when you compile your shared module for Android, it will include everything that's on the left in the Android directory and everything in the middle, which is your common code, and generate the library based on all of that code. And then you've got a similar thing for iOS. Your Kotlin code in the iOS directory can access iOS platform stuff. So also Bluetooth and other iOS frameworks that you may need to use from your shared code is all accessible in Kotlin in your shared module. And then when you compile for iOS, it packages all of that plus your common code into your iOS framework that you can then consume from Swift. So here's the basic organization of code in your shared module. If you go beyond KMM, the diagram gets a lot more complicated since there's a lot of targets and some of them overlap with each other. But basically, it's the same principle of you have shared code for all platforms and you have platform specific code uh, that has access to platform specific APIs. So, what are the best ways to get started with KMM? The most straightforward is there is a KMM plugin for Android Studio. Once you install that, if you go to the new project wizard, you'll have a new option when creating a project, and that'll just be an option to create a Kotlin multi-platform app instead of an Android app. From there, it lets you configure a lot of things like application names and how you want iOS to consume your framework that gets generated by your shared module. And once you hit finish, you'll have a functional Android and iOS app that are both using code from a shared module in Kotlin. There's also a wizard on IntelliJ, which gives you a lot more options, especially if you're trying to do things beyond mobile platforms. But if you're just trying to do mobile, the Android Studio wizard is enough to get you going. Another option that we at Touchlab suggest is our CampKit repo. It's a more fully featured project template than either of the wizards gives. They give pretty basic Hello World type apps. CampKit is meant to be a more fully fledged functioning app, so it uses network request and database persistence, and also uses Swift UI and Jetpack Compose to show off a more realistic view of what a Kotlin multi-platform mobile app can look like. Uh, we use it to make sure that we're showing off all of our best practices and preferred libraries so that you can kind of get a gauge on what we think is the best things to use and the best way to handle things just by looking at this simple example. So the idea of CamKit is that you can fork the repo, run it right away without any extra configuration, and then edit it to play around and experiment with Kotlin Multiplatform Mobile in a new project that's already set up and has all the libraries that you might want to try out. And we actually often use it internally to start off a project. So it's not just for the public, it's also for us. Uh, so whenever we're starting with a new client, we often just fork CampKit and then change everything to fit that client's needs. So when writing common code, you can put in anything that doesn't use platform specific APIs. For the most part, if you have code that doesn't do that in your Android app, you can probably just pull that into your shared module and it'll run on iOS for free. Um, if you're using any KMP libraries that provide a shared interface, you can also use all of those in your common code without worrying about interacting with the platform and just letting the KMP library handle all of the platform stuff. So usually we're sharing business logic, which is definitely the easiest thing to share because it's very platform agnostic and has a lot of value in making sure that the business logic on iOS and the business logic on Android not only have the same behavior, but are running on the exact same code. So you can guarantee that there's not going to be any difference in how your Android and iOS app are doing things. Data models is another really easy win for KMM since those are also just basic plain Kotlin objects where you can just use the exact same models on Android and iOS without worrying about any divergent behavior due to implementation details. And then we also typically share network and database logic using various libraries, since that also doesn't usually need to differ between Android and iOS. So here's a snippet of something you might have similar looking code to in your Android app. This is the kind of thing that, since it doesn't do anything with Android or JVM or anything specific like that, you can just take this code and drop it right into your shared module and use it from Swift right away. So that's all great if you never actually have to interact with the platform, but it's really unlikely that you're not going to have to do that. So what happens when you do? One way to do it is the expect actual functionality. Expect actual is a new set of keywords that's added to the Kotlin language by Kotlin Multiplatform. And basically, the way it works is you write something that you expect to exist in your common code. So here we're expecting that there's a string property called platform at the top level. But we don't provide any implementation since this platform is going to change based on what platform we're running. And then you write the actual implementation in each of your platform directories. So here we use the actual keyword to say the actual implementation of the platform property is Android or iOS. And then at compile time, the compiler picks which actual to use based on the platform that you're targeting for that build, and that will replace any usage of the expect value in all your shared code. This can be used for any top level declarations, so that's functions, properties, classes, objects, and interfaces. And it can be really useful, but it's also super easy to overuse. So I usually see expect actual as like a shiny new hammer where you get into Kotlin Multiplatform and you see this and it seems to work like magic and solve all of your problems with dealing with the platform. But as you do more development in KMP, you're going to see a lot of screws. So this hammer that you've just found, it'll work, but it's not necessarily the best tool for the job. Um, the issues are that implementations are forced in at compile time, so you have no way at runtime to swap out what implementations you're using. And because of that, it's really difficult to test. So you have no way to put in, for example, for the platform property, you have no way to put in a test variant of that expect actual. If it's running your test for Android, it will always be that Android implementation, and the same thing for iOS. And in the same vein, you also can't have multiple implementations on one platform. If the compiler sees two actual implementations for one expect on one platform, it's just going to blow up and fail your build because it has no idea which one to pick. So you're wondering, what's the screwdriver then if you don't want to be hammering screws into your app? And the good news is you actually already have it. It's interfaces. So what you can do is you can declare an interface in common code and all of your common classes can just depend on it. So here we have a logger. And all it does is it has a log function that takes a string and writes it to some log. And the common code doesn't really care how that's implemented. It just knows I need something with this function. So then on your platforms, you just implement that interface using your platform specific API. So here we have the Android logger and the iOS logger. The Android logger, since it's in the Android directory, is going to have access to your logcat logger. And the iOS logger, you can use OS log or whichever, or just printline or any other logger that you like using on iOS. And then you just inject these implementations through dependency injection. The other benefit of interfaces is that you can actually implement them in Swift directly. So if you have something that you want to wrap and you already have some code in Swift that does the job, you can use Swift to implement that interface and then just pass the implementation into your common module. And all of your common Kotlin code is going to be using this Swift logger when it's running on iOS. And you can also just swap out what you're using at runtime for other implementations like tests. So if you want a test logger that just does nothing or prints just to the console, then you can do that and really easily swap out which implementation you're using whenever you need to. So it's a lot more flexible than expect actual. It makes the code way more testable, which is kind of the same as just using interfaces in non KMP code. Because if you've done enough large scale development with a lot of testing, you'll know that depending specifically on implementation classes makes your app harder to test. So the same is true for Kotlin Multiplatform, which is why we prefer to use interfaces wherever possible. And the only difference is the implementations are on completely different platforms. There are still use cases for expect. We often use it for things like top level functions and properties of like small little snippets of code that we want to be different based on the platform it's running, but we don't necessarily want to wire up everything to inject it via DI or anything like that. So some big libraries that we use a lot in all of our projects are Ktor by JetBrains, and that will handle all of your networking and HTTP stuff in common code. If you're used to using like retrofit on Android, then this is a pretty straightforward replacement. There's SQLite by Square that lets you share database code, so you can set up a schema and interact with the database in common without worrying about what platform you're on, and it'll handle the platform stuff for you. I think SQLite is just like one of the better SQL libraries I've used in general for Android. So it's kind of just a bonus that it's also KMM enabled. We actually worked with Square, and we got the driver working for iOS to make this really good library that they already had out usable for iOS as well. If when you look at SQLite, it will be a bit different from a lot of other SQL libraries you're used to. Most SQL libraries like Room will have you writing Kotlin classes with annotations or some other way to wire it up with a library, and then it'll generate the SQL code and other Kotlin code for you to interact with your database. SQLite, on the other hand, uses SQL code as your source of truth. So you will actually write the tables and the interactions in SQL, and SQLite will generate the Kotlin code to represent that data and to interact with that database for you. So it's a bit of a learning curve just using SQL instead of Kotlin, but I think it makes for a much more robust framework. Um, with the added bonus that you can use it on Android and iOS and only have to write your database schema once. For logging, we use Kermit, which is by us. We're obviously biased here. There's other logging libraries that exist, but we use ours. Uh, Kermit supports a lot of platforms beyond the mobile platform. So we also support JS on the browser and in Node, the desktop targets and things like that. And we also handle some crash reporting stuff. So if you want to set up automatic crash reporting for, say, Crashlytics, we have a Kermit module that will wire that up for you, since it can be a little tricky to get readable stack traces from Kotlin crashes that are running on iOS to show up in Crashlytics, and Kermit will handle that for you. We use Coin for dependency injection. We think using a DI framework instead of just manual injection makes everything easier, especially when you're using interfaces a lot instead of expect actual. It'll really help push you away from leaning on the expect actual um, method of sharing code, because it just makes using interfaces a lot easier than it would be if you had to manually inject things. And the last option is just make your own. KMM is relatively new, so you may not find a library that handles all the platform stuff that you need to do. And I think a lot of people initially are afraid to really get down and dirty when it comes to making like a shared SDK for interacting with the platform, and will tend to share less in order to do more natively. But I think if you lean on stuff you already know, like interfaces and the native implementation of what you want to do, it's going to be surprisingly easy to create a shared interface that you can then use in your Kotlin shared code to pull more and more logic out of those native platform and reduce even more redundancy in your app. So an example is from the library Multiplatform Settings by Russell Wolf, who's a coworker of mine. This is a library for interacting with the key value storage APIs on each platform. So like shared preferences on Android, but doing that from common code. So to start off, like you would normally do when you want to be able to have different implementations of something without changing client code, you just make an interface that defines the behavior that you want out of that API. The only difference here is that you might want to keep in mind when writing the shared API, that is, where is this interface going to be used? So if it's just going to be used internal to your shared module, only from Kotlin, then there's not too much you have to worry about. But if this interface is going to be on the Kotlin Swift barrier and you want to be able to use this from Swift, then you want to take some considerations in terms of what your API looks like from Swift instead of just from Kotlin. Namely, there's the fact that suspend functions and flows aren't really easily consumable directly from Swift. So if you have functions that are suspending or return flows or just anything async, you can use the suspend functions, but you lose out a lot of the benefits of using coroutines like cancellation and scopes and things like that. So in this case, you can either switch to just a callback based API for your interface, or one thing we do a lot is we just write a wrapper around the interface that lets us adapt the coroutines code to callbacks. so that on Android we still get direct access to the suspend functions and flows without having to wrap anything, but iOS and Swift is still able to consume it in a more fluent way. And this will also let you, on the iOS side, take those callbacks and then wrap them again in, say, like Combine or Swift Async or RX Swift or any of your other asynchronous programming libraries that you like to use on Swift. So you don't need to change your paradigms and how you interact with things. You can just wrap the Kotlin code in Swift code to be able to use it fluently. At Touchlab, since we usually keep everything up to and including the view model in shared code, we keep everything underneath Kotlin first. So we use a lot of flows, a lot of spend functions. Default argument values are another thing that don't get translated across the Kotlin Swift barrier. But if you aren't using it from Swift, then you don't have to worry about that. And then we just have our view model classes handle lifecycle, cancellation, and then wrapping all of that up in a way that's consumable from Swift. So Swift has this like single entry point into the shared module through the view model, which is going to be tailored specifically to consuming from Swift. And then, so for the implementation on Android, we just implement the interface with shared preferences by just taking a shared preference in and delegating all of our calls through it. So if you've used shared preference before, this probably looks deceptively easy, but it really is just that simple of use what's on the platform, implement the interface, and then just call the platform stuff. So on iOS, we have basically the same thing, but we're using NS user defaults instead. And that's really all there is to it. You just write your interface, implement it using a wrapper around a platform API, and then all you have left to do is to inject the appropriate implementation in with DI or manually or however you want to do that. And then just like that, with just the code you've seen on these slides, you can have access to each platform's key value storage in common code without having to worry about what platform you're running on. And you can follow the same general approach for most interactions with the platform. So as long as you can figure out how to do it on Android and iOS independently, then you can probably just make a shared interface for it. So another trap that people fall into is looking specifically for how to do X in Kotlin multi-platform, when what you can do is say how to do X in Android and how to do X in iOS. And then you know how to write an interface. So you have everything you need to do that in Kotlin multi-platform without having to find someone who's already done it before. And since we have flexibility with interfaces over expect actual, you can also create multiple different implementations for different use cases and tests. So, like in multi-platform settings, there's actually an implementation that uses the iOS keychain for when you need to store private information, and that can at runtime just be swapped out for this NS user defaults implementation, and you'll go from writing not secured data to secure data. And then the other benefit is that if you already have implementations on each platform, or you have a bunch of code that you've written to handle some core use case or platform interaction on your app, or you have a library that you use already that you like to let handle all of your platform stuff, then you can just make an adapter and wrap that code that already exists and you've been using for as long as you've had an app, and then use that in shared code without worrying about platforms by just adhering to the interface that you create. And I actually recently did this when trying to share Bluetooth code. So there's a couple KMM Bluetooth libraries, but they're not as mature as some of the native libraries, some of the like single platform libraries. And the client was a little weary about using these really new, not so well battle tested libraries on KMM, but they were okay with using the decade old Android specific library that was way more mature and had a lot more eyes on it and a lot more battle testing. So what we did was just write the interface for interacting with Bluetooth, and then on Android side, we just wrapped that library and we called through to the library instead of using the Android I directly, which if you've ever done any Android BLE stuff, you'll know that saves like a lot of time because that API is not very good. And so we were able to get that done really quickly while still giving the client the assurance that we weren't just using any library just because it's Kotlin multi-platform supported, even if it's not very stable or vetted, or if it's in like a 0.0.1 alpha version. So you can use like whatever you want on the platform side. And that's it. You can find me on Twitter. I'm also on the Kotlin Link Slack. Feel free to shoot me a DM or tag me. And we at Touchlab, we're also doing contracting consulting. So if you think you need help, like at an organization level, you can reach out to us through our website to maybe hire us and work with us. And we're also hiring. So if you really like Kotlin Multiplatform, you can apply and do it full time with me.
Wow, this is a very fantastic presentation. Thank you so much, Michael, for this awesome presentation. This is actually my first exposed to the multi-platform mobile, and it does lead me to a quick question. I'll let you drink your water, coffee.
Go ahead.
So what kind of future do you see with this multi-platform? Like, how you see? Do you see like you think the majority of the consumers or users will be using this compared to others?
So I think the big differentiator between this and all of the other things that I know like a lot of people have been burned by, like Xamarin and React Native, is that you're not dependent on it existing. So I think like because there's such a low bar to entry and there's such a low commitment, I do see like it growing a lot in adoption. Because like even in the unlikely and unfortunate scenario that JetBrains just gives up on Kotlin multi-platform, your app's still going to build, and that code that you already have is still going to work. It's not going to just stop working, but you still have these native iOS and Android apps, so you can just stop using KMP for new stuff, which I think is like the big differentiator between this and other technologies. So I do see like it growing a lot, and I have seen like in the time that I've been doing it, the speed of like adoption and maturity that it's gained has been like really quick and interesting to see.
That's pretty cool. And let's say, for example, for those who are seeking to go more in depth about this multi-platform, what is the best resources that you have that you could share?
So JetBrains has pretty good docs, especially as they approach beta. They've been doing a lot of work to clean up their docs. In the earlier phases, when they were in alpha and earlier, the docs tended to sometimes be like old or out of date or didn't quite work right. But the JetBrains docs now are like really good. CampKit has a lot of, if you really want to see like how a Kotlin multi-platform app works, then CampKit is a really good thing to just look over and try to understand. There's also a couple other samples that we recommend. John O'Reilly's People in Space repo is another really good one. His is really cool because it supports beyond the mobile targets. So there's a lot of different targets on his, and they all share this common code. So you have like, I think desktop and browser and iOS and Android and Apple Watch all sharing code for their business logic.
It's pretty cool. Fantastic. Anyone else would like to share some questions or comments about this awesome topic before we wrap up? And also, I want to take up this chance to really thank you and Touchlab for supporting Women Who Code and being an awesome partners.
For sure, yeah, we're glad to be a part of this. Looks like there's a couple questions in the Q&A section, so I can go through those. Is there a way to share those? Do you know on screen, or do I just share my screen on that slide?
Let me check real quick. I don't think so, but I will definitely can read them out to you if you like. So Aaron says, for existing projects that have large native code bases, how we suggest approaching KMM? Any common themes for features are easier to migrate?
Yeah, that's a really good question. So, especially for large code bases, we recommend starting small and either starting with something new or starting with something that is low risk in terms of affecting your app or um, not time sensitive. So, a big thing that is like an easy win is analytics because usually you want to log the same analytics events for Android and iOS, and that's a pretty straightforward thing to put into shared code so that both of your apps are interacting with the same analytics API. Another approach is you just kind of pick a feature that is upcoming and pick a champion who's going to own implementing that specific feature in Kotlin Multiplatform and see how it works for your organization and then assess from there.
Okay, and we have one from Anastasia saying, so in terms of clean architecture, basically in common code goes the domain layer, right? I think the
Yeah,
that's
so
not what you're talking
usually
about.
it depends. So you have the flexibility of choosing like where you draw that line. If you're thinking in terms of clean architecture, the domain layer is probably the most straightforward place to draw that line. Um, I guess depending on what you consider a view model, like what layer of that architecture, uh, it might be a little different, but you can go as deep as like the service layer and only share that, or you can go as high as, like I said, with the new library coming out, Compose Multiplatform. It's actually basically Jetpack Compose being worked on by JetBrains, but it supports like the browser and it has other platforms probably coming out soon, maybe iOS. So at some point, you may be able to actually share all the way up to the view layer with Compose Multiplatform. But with the flexibility of just putting code into the shared module and using it, it's really up to you where you want to draw that line. But yeah, the domain layer is like the most straightforward uh, and easiest win for drawing the line.
And another question from Anastasia. Why do you specify public keyword, for example, in the settings interface example?
So that's actually just because it's a library. It uses Gradle's or Kotlin explicit API mode, which is just a way to make sure that you're more disciplined about what you're exposing by forcing you to explicitly declare what's public and what's not. So that's just specific to that library. You don't need to declare public. It isn't a multi-platform thing.
Good. And here's a question from Jay. Any compatibility issues when using KMM for iOS? Is there a list of no limitations which we can refer to?
Not really. Nothing comes to mind, at least in terms of like a list of things. I've been doing it for a year and a half, and I can't think of anything that I've run into that I couldn't use on iOS because we were doing KMP. And that's mostly just because you're just pulling in your shared code as an iOS framework. So as far as Swift is concerned, it's just like another Objective-C framework that you're using. And it doesn't really have to think about, like what are the implications of pulling this in coming from Kotlin. So that's not to say that there isn't like anything. I just haven't run into anything that I can think of off the top of my head.
Thank you so much.
Thanks.